Welcome to Ask and Learn.
In this problem, we're dealing with a roller coaster, and we want to find the required height for the car to reach 100 miles per hour when it goes from point A all the way to the bottom at point B. So again, the velocity we are given is 100 kilometers per hour. Let's convert that to make it a little easier. So we have 1 hour, 60 minutes, 1 minute, 60 seconds, and then let's get rid of the kilometers. So we have 1 kilometer is 1,000 meters. So as you can see, hours cancel, minutes cancel, kilometers cancel. So now our speed after converting is 27.8 meters per second. And again, this is the speed that we want the car to have when it reaches the bottom at point B. So normally when you're dealing with a height, you know that there has to be some sort of potential energy. And in this case, since the car is also moving, we know that there has to be a kinetic energy because of the movement. So that means we can use the conservation of energy equation. So we have kinetic energy initial plus potential energy initial will equal kinetic energy final plus potential energy final. And since the cart is at rest at point A, that means it has zero velocity, so its initial kinetic energy is 0. And when it reaches at the bottom at point B, that means its height, looking back at the picture, the height is 0. So our potential energy final will be 0. So now we're left with potential energy initial, which is mass times gravity times height initial, is equal to final kinetic energy, which is 1/2 m velocity final squared. So what we're looking for is the initial height. So now we just solve for h. So hi is equal to 1/2, and then the m's cancel, so you have 1/2 velocity final squared divided by gravity. And of course, now you can plug in your numbers. So velocity 27.8 squared divided by 9.8. So the height we want is height initial is equal to 39.4 meters. Now the next part of the question, we want to find the radius of curvature at point B. So if this was a better drawn picture, at point B we would have half of a circle here, and then this would complete a nice looking circle here. So we're looking for the radius of curvature rho right here. Okay, so we know when the car is at that point B, if we draw a free body diagram, we know that we have the weight pushing down, which is mg, and then a force in the opposite direction called the normal force. So at this point, the sum of the forces in the y direction will equal Fn minus, and then we have the weight pushing negative is down, so the weight is negative, minus mg will equal mass times acceleration. And here, the acceleration will be the centripetal acceleration. So A will be v squared divided by the radius of curvature, rho. So this is what I want to solve for. So now let's plug in f of n because it's given. So we have 39.24 times mass minus mass times gravity is equal to mass times velocity squared divided by rho. As you can see, every part has an m, so we can cancel that. Now we can solve for rho. So we have rho is equal to v squared divided by that 39.24 minus gravity, which is 9.8. So plugging in our velocity, we get rho, the radius of curvature, to be 26.25 meters.